Romex, specifically an MB cable, is not suitable for outdoor wet locations due to its PVC polyvinyl chloride jacket. This jacket is not designed to withstand exposure to moisture and ultraviolet radiation. Outdoor conditions can degrade the PVC jacket by undermining the insulation and the protection of the conductors. When moisture penetrates the Romex cable, it can lead to electrical short circuits, ground faults, and potential shock hazards. THHN cable, on the other hand, is required for outdoor wet locations. THHN cable possesses a thermoplastic, heat-resistant insulation that is ultraviolet resistant and capable of enduring outdoor conditions. The N in THHN indicates that the insulation is moisture-resistant and suitable for wet environments. THHN cable is specifically engineered to shield conductors from moisture, abrasion, and sunlight. Regarding specific requirements for pool light wiring, the electrical code, specifically the National Electrical Code, necessitates the use of THHN wire for wiring pool lights and other submersible fixtures. Submersible fixtures are consistently exposed to moisture and may require replacement or repair, underscoring the importance of employing a durable and moisture-resistant cable. THHN wire ensures a secure and dependable connection for pool lights, mitigating potential electrical hazards. It is crucial to adhere to these code requirements to maintain safety and prevent electrical issues. The NEC guidelines are in place to protect individuals from electrical hazards and ensure the proper functioning of electrical systems, particularly in sensitive environments such as around swimming pools. The use of Romex in outdoor or wet locations is a violation of these codes due to its inherent limitations in moisture resistance and UV protection. The degradation of Romex cable in such conditions can lead to serious safety risks, including electrical shock and fire. Therefore, it is essential to replace any Romex wiring with THHN cable when dealing with outdoor or wet environments, especially for pool lights. When installing THHN wire and conduit, it is important to follow proper wiring practices. Firstly, ensure that the conduit is appropriately sized to accommodate the number and gauge of wires being installed. Secondly, use the correct fittings and connectors to maintain a watertight seal and protect the wires from damage. Thirdly, properly ground the conduit system to provide a path for fault current and reduce the risk of electrical shock. The National Electrical Code provides detailed guidelines on conduit installation, including fill ratios, support requirements, and grounding methods. Compliance with these guidelines is essential for ensuring the safety and reliability of the electrical system. In addition to the type of wiring, the installation of pool lights must adhere to specific requirements outlined in the NEC. These requirements cover various aspects, including bonding, grounding, and the use of ground fault circuit interrupters, or GFCIs. Bonding involves connecting all metallic parts of the pool and its surrounding structures to create an equipotential plane, which minimizes voltage differences and reduces the risk of electrical shock. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and disconnecting the power supply. GFCIs are designed to detect small imbalances in current flow and quickly shut off the power, preventing electrical shock. The NEC also specifies the minimum depth at which pool lights must be installed, as well as the type of junction boxes and enclosures that can be used. These requirements are intended to ensure the safety of individuals using the pool and to prevent electrical hazards. When selecting THHN wire for pool light wiring, it is important to choose the correct gauge based on the amperage of the light fixture and the length of the wire run. The NEC provides tables that specify the allowable ampacity of different wire sizes, taking into account factors such as insulation type and ambient temperature. Using an undersized wire can lead to overheating, insulation damage, and even fire. It is also important to use a wire that is rated for wet locations, as some THHN wires are only rated for dry locations. The wire should be clearly marked with its rating and gauge. In addition to the wiring and installation requirements, it is important to regularly inspect and maintain pool lights to ensure their continued safety and reliability. This includes checking for signs of damage, such as cracks, leaks, or corrosion. It also includes testing the GFCI protection to ensure that it is functioning properly. If any issues are detected, the pool light should be repaired or replaced by a qualified electrician. Proper maintenance can help prevent electrical hazards and extend the life of the pool lights. The use of Romex cable in outdoor applications, particularly in wet locations, poses a significant risk due to its susceptibility to moisture and UV damage. The degradation of the cable's insulation can lead to electrical shorts, ground faults, and potential shock hazards. Therefore, it is essential to replace any Romex wiring with THHN cable or another approved wiring method when dealing with outdoor or wet environments. This is especially critical for pool lights, where the risk of electrical shock is heightened due to the presence of water. THHN cable is specifically designed to withstand the harsh conditions of outdoor and wet environments. Its thermoplastic insulation is resistant to moisture, UV radiation, and abrasion, providing long-lasting protection for the conductors. The N in THHN indicates that the insulation is moisture-resistant and suitable for wet locations. THHN cable is also available in various sizes and colors, allowing for easy identification and installation. When installing THHN wire, it is important to follow proper wiring practices to ensure a safe and reliable electrical system. This includes using the correct size of conduit, fittings, and connectors. It also includes properly grounding the conduit system and bonding all metallic parts of the pool and its surrounding structures. The National Electrical Code provides detailed guidelines on wiring practices, which should be followed carefully. In addition to the wiring and installation requirements, it is important to consider the type of pool light being used. There are various types of pool lights available, including incandescent halogen and light-emitting diode (LED) lights. LED lights are becoming increasingly popular due to their energy efficiency, long lifespan, and low maintenance requirements. LED lights also produce less heat than incandescent or halogen lights, which can help reduce the risk of overheating. When selecting a pool light, it is important to choose one that is specifically designed for underwater use and is listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. The light should be properly sealed to prevent water from entering and causing electrical shorts. It should also be installed at the correct depth and distance from the pool's edge, as specified by the manufacturer. The Electrical Code, NEC, provides specific guidelines on the installation of pool lights, including requirements for bonding, grounding, and GFCI protection. Bonding involves connecting all metallic parts of the pool and its surrounding structures to create an equipotential plane, which minimizes voltage differences and reduces the risk of electrical shock. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and disconnecting the power supply. GFCIs are designed to detect small imbalances in current flow and quickly shut off the power, preventing electrical shock. These safety measures are essential for protecting individuals using the pool from electrical hazards. In addition to the technical aspects of pool light wiring, it is also important to consider the aesthetic aspects. Pool lights can enhance the beauty and ambience of a pool, creating a relaxing and inviting atmosphere. There are various colors and styles of pool lights available, allowing homeowners to customize their pool's appearance. LED lights are particularly versatile, as they can be programmed to display a wide range of colors and patterns. When choosing pool lights, it is important to consider the size and shape of the pool, as well as the surrounding landscape. The light should be positioned to provide adequate illumination without creating glare or shadows. They should also be integrated seamlessly into the pool's design. Regular maintenance is essential for ensuring the safety and longevity of pool lights. This includes inspecting the lights for signs of damage, such as cracks, leaks, or corrosion. It also includes testing the GFCI protection to ensure that it is functioning properly. If any issues are detected, the pool light should be repaired or replaced by a qualified electrician. Proper maintenance can help prevent electrical hazards and extend the life of the pool lights. Finally, it is important to remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to handle the installation or repair of pool lights. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes and regulations. In summary, the use of Romex cable in outdoor or wet locations, such as for pool lights, is a violation of the National Electrical Code, NEC, and poses a significant safety risk. THHN cable is the appropriate wiring method for these applications due to its moisture resistance and UV protection. Proper installation, bonding, grounding, and GFCI protection are essential for ensuring the safety of individuals using the pool. Regular maintenance and inspection are also important for preventing electrical hazards and extending the life of the pool lights. And remember, when in doubt, consult a qualified electrician. Now let's delve a bit deeper into the specifics of why Romex is unsuitable for outdoor environments and why THHN is the preferred choice. Romex, or an MB cable, is primarily designed for indoor, dry locations. Its outer jacket, typically made of PVC, is not resistant to the degrading effects of moisture, sunlight, and temperature fluctuations. When exposed to these elements, the PVC jacket can become brittle, crack, and lose its protective properties. This can lead to the insulation on the individual conductors inside the cable being compromised, increasing the risk of short circuits, ground faults, and electrical shocks. Furthermore, the conductors within Romex are typically insulated with a material that is not specifically designed for wet locations. If moisture penetrates the cable, it can cause corrosion of the conductors, further increasing the risk of electrical failure. In contrast, THHN cable is specifically designed for use in both wet and dry locations. Its thermoplastic insulation is resistant to moisture, chemicals, and abrasion. The N in THHN stands for nylon, which provides an additional layer of protection against moisture and abrasion. THHN cable is also typically rated for higher temperatures than Romex, making it suitable for use in a wider range of applications. When used in outdoor applications, THHN cable is typically installed in conduit, which provides additional protection against physical damage and environmental factors. Conduit is a rigid or flexible tube that encloses and protects electrical wiring. It is available in a variety of materials, including PVC, metal, and fiberglass. The type of conduit used will depend on the specific application and the environmental conditions. For example, PVC conduit is commonly used in underground applications due to its resistance to moisture and corrosion. Metal conduit is often used in exposed locations where it is subject to physical damage. When installing THHN cable and conduit, it is important to follow the National Electrical Code (NEC) guidelines for conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC specifies maximum fill percentages to ensure that the conductors are not overcrowded, which can lead to overheating and insulation damage. The NEC also specifies requirements for conduit supports, bonding, and grounding. These requirements are intended to ensure the safety and reliability of the electrical system. In addition to the type of wiring and conduit, it is important to consider the type of junction boxes and enclosures used in outdoor applications. Junction boxes and enclosures are used to protect electrical connections from the environment. They are available in a variety of materials, including metal, plastic, and fiberglass. The type of junction box or enclosure used will depend on the specific application and the environmental conditions. For example, weatherproof junction boxes are commonly used in outdoor applications to protect electrical connections from rain, snow, and sunlight. Weatherproof junction boxes are typically made of a corrosion-resistant material and have a gasketed cover to prevent water from entering. They should be installed in accordance with the NEC guidelines. In addition to the technical requirements, it is also important to consider the aesthetic aspects of outdoor electrical installations. Outdoor electrical equipment should be installed in a way that is both safe and visually appealing. For example, conduit can be painted to match the color of the surrounding building. Junction boxes and enclosures can be hidden behind landscaping or other architectural features. The goal is to create an electrical system that is both functional and aesthetically pleasing. Finally, it is important to remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not comfortable working with electricity, it is best to hire a licensed electrician to handle the installation or repair of outdoor electrical equipment. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes and regulations. The difference between Romex and THHN cable is crucial for understanding electrical safety. Romex, also known as NMB cable, is primarily intended for indoor use in dry locations. Its PVC jacket is not designed to withstand the rigors of outdoor environments. This means that exposure to moisture, UV radiation, and extreme temperatures can lead to degradation of the jacket, compromising the insulation and exposing the conductors. THHN, on the other hand, is specifically engineered for both wet and dry locations. Its thermoplastic insulation is more resistant to moisture, heat, and abrasion. The nylon covering provides added protection. This makes THHN a much safer and more reliable choice for outdoor applications, particularly those involving pool lights where constant exposure to moisture is a given. When it comes to pool lights, safety is paramount. The National Electrical Code, NEC, sets strict standards for their installation to minimize the risk of electrical shock. These standards include the use of THHN wire, proper grounding and bonding, and the installation of ground fault circuit interrupters, or GFCIs. Grounding involves connecting all metal parts of the pool and its equipment to a common ground, ensuring that any stray electrical current is safely diverted. Bonding is similar to grounding but involves connecting different metal parts together to create an equipotential plane, minimizing voltage differences. GFCIs are designed to detect even small imbalances in electrical current and quickly shut off the power, preventing potentially fatal shocks. In addition to these safety measures, it is also important to consider the type of pool light being used. LED pool lights are becoming increasingly popular due to their energy efficiency, long lifespan, and low voltage operation. Low voltage lights are inherently safer than high voltage lights, as they reduce the risk of electrical shock. Regardless of the type of pool light used, it is essential to follow all NEC guidelines for installation and maintenance. This includes using the correct wiring methods, ensuring proper grounding and bonding, and regularly inspecting the equipment for signs of damage. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to handle the installation or repair of pool lights. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in compliance with all applicable codes and regulations. The reason Romex cable is not permitted for pool light wiring, especially when run through outdoor PVC conduit, boils down to its unsuitability for wet locations and potential degradation when exposed to the elements. Romex, or NMB cable, is designed for indoor, dry environments. Its outer jacket, while providing some protection, is not resistant to moisture, UV radiation, and temperature fluctuations that are common in outdoor settings. When Romex is exposed to these conditions, the outer jacket can deteriorate over time, leading to cracks and breaches in the insulation. This allows moisture to penetrate the cable, potentially causing corrosion of the conductors and increasing the risk of electrical shorts, ground faults, and shocks. In contrast, THHN thermoplastic high-heat nylon wire is specifically designed for use in both wet and dry locations. The N in THHN indicates that it has a nylon outer covering that provides additional protection against moisture and abrasion. When used outdoors, THHN wire is typically installed within a conduit such as PVC conduit to provide further protection from the element and physical damage. However, even when installed in conduit, Romex is not an acceptable substitute for THHN in wet locations. The conduit itself can accumulate moisture due to condensation or water intrusion, creating a damp environment that can still degrade the Romex cable over time. The National Electrical Code, NEC, clearly specifies the types of wiring methods that are permitted for use in various locations, including those that are considered wet or damp. For pool lights and other submersible fixtures, the NEC requires the use of wiring methods that are specifically listed for such applications, such as THHN wire installed in a suitable conduit. These requirements are in place to ensure the safety of individuals using the pool and to prevent electrical hazards. In addition to the wiring method, the NEC also has specific requirements for grounding and bonding of pool lights and related equipment. Grounding provides a path for fault current to return to the source, tripping a circuit breaker or fuse and disconnecting the power supply. Bonding involves connecting all metallic parts of the pool and its surrounding structures to create an equipotential plane, minimizing voltage differences and reducing the risk of electrical shock. Ground fault circuit interrupters, or GFCIs, are also required for pool circuits to detect small imbalances in current flow and quickly shut off the power, preventing electrical shock. When installing pool lights, it is essential to follow all NEC guidelines and local electrical codes to ensure a safe and compliant installation. This includes using the correct wiring methods, ensuring proper grounding and bonding, and installing GFCIs. It is also important to use qualified electricians who are familiar with the specific requirements for pool electrical systems. In summary, Romex cable is not suitable for pool light wiring, even when run through outdoor PVC conduit, due to its lack of resistance to moisture and potential for degradation in wet environments. THHN wire is the preferred choice for these applications, as it is specifically designed for use in both wet and dry locations and provides a high level of protection against electrical hazards. Following the NEC guidelines and using qualified electricians are essential for ensuring a safe and compliant pool electrical system. Consider the specific code articles within the NEC related to swimming pools, Article 680. This article provides comprehensive requirements for the construction and installation of electrical systems associated with swimming pools, including wiring methods, grounding and bonding, and GFCI protection. Within Article 680, there are specific sections that address the wiring of underwater luminaires, which are commonly known as pool lights. These sections detail the types of wiring methods that are permitted, as well as the requirements for conduit, junction boxes, and other related equipment. Understanding these specific code requirements is essential for ensuring a safe and compliant pool electrical system. Furthermore, it is important to note that local jurisdictions may have additional requirements or amendments to the NEC that must be followed. It is always advisable to consult with local building officials or electrical inspectors to determine the specific requirements in your area. The electrical inspector's rejection of Romex for your pool light installation highlights the importance of adhering to these codes and regulations. The inspector is responsible for ensuring that all electrical work meets the minimum safety standards and that the installation is in compliance with the applicable codes. By pointing at the use of Romex and requiring it to be replaced with THHN, the inspector is preventing a potentially hazardous situation and ensuring the safety of the pool users. In addition to the safety aspects, using the correct wiring methods and materials can also prevent future problems and expenses. Using Romex in a wet location can lead to premature failure of the cable, requiring costly repairs or replacements. Using THHN wire and following the NEC guidelines can ensure a long-lasting and reliable electrical system. Therefore, while it may seem like an inconvenience to replace the Romex with THHN, it is ultimately a worthwhile investment in the safety and reliability of your pool electrical system. Remember to always prioritize safety and consult with qualified professionals when dealing with electrical installations, especially in potentially hazardous environments such as swimming pools.